4, and then start in on 2.5, and we get to the majority of 2.5 as well. Okay. All right. So last time we looked at one-sided limits, and we also looked at a specific limit in trigonometry that is going to be very important to us. Last time we looked at this limit as theta goes to 0 of sine of theta over theta. And again, sort of the argument that we use to evaluate this limit is we use sort of this geometry argument as well as this sandwich / squeeze theorem argument. And then we also looked at the fact that this function has some asymmetry to identify that this limit is equal to what? What did we evaluate this limit as? 1. So this limit is in fact 1. Okay. Today what we're going to do is we're going to look at a couple of problems that involve finding limits with trig functions. And this limit, this particular limit, shows up frequently enough that we'll utilize it to evaluate many of these limits. Okay. All right, so let's start off with some simple problems. Let's find some of these limits. And the first one we'll look at again, limit as theta goes to 0 of sine of 2 theta divided by theta. The second one after that, oops, sorry, 2 theta down there, a little easier to start with. Limit as theta goes to 0 of 1 minus cosine theta. Okay, so let's take a look at these two limits first, and then we'll progress on to some others as well. This first one here, as you look at it, we're looking at the sine of 2 theta divided by 2 theta. We want to know what happens to this function if we get really, really, really close to 0. Okay. Well, if you look at this limit and you compare it with the one that we evaluated last time, what's the difference between this limit and this one up here? The only difference that I can see is there's a 2 theta inside the parentheses, and there's a 2 theta in the denominator. Okay? Well, all right. Well, what happens to 2 theta as theta gets closer to 0? What happens to the product of 2 and theta as we get closer and closer to 0? What happens to it? This goes to 0, right? Thing inside parentheses also goes to 0. So again, we can rewrite this limit slightly. And let's see, I need a letter. We'll go with phi. We're going to learn most of the Greek alphabet while we're in here, so don't worry. Limit as phi goes to 0 of sine of phi divided by phi. Okay? Now, when I write it this way, what's this limit have to be equal to? This limit has to be equal to 1, because this limit is exactly the same as this limit up here, right? So this is still equal to 1. And all we've done here is we've made the substitution that phi is equal to 2 theta. And the nice thing is that since 2 theta goes to 0 as theta goes to 0, phi also goes to 0 as theta goes to 0. That's the key thing here. We can make replacements to parts of our limit as long as the things we're replacing with do what we need them to do. In this case, theta goes to 0, theta goes to 0, so 2 theta is also going to go to 0. So we can rewrite limits using alternate variables, alternate lettering and phrases in there, as long as the things that we're replacing have the same behavior as the original thing we wanted. Okay? Before we get to number 2, let's do a 1b. Okay? Let's look at this limit. Limit as theta goes to 0, the sine of 3 theta divided by theta. All right. Now, we look at this limit for a minute, and we compare it with what we've been doing. Okay? And you may look at it and you say, okay, well, it looks similar to what we've been doing, but there are some subtle differences, right? what's the problem with just making the exact same type of substitution that we did over here to this problem? Okay, we're missing a 3 in the denominator, right? We're missing a 3 in the denominator. So, all right, well, we're missing a 3 in the denominator. Let's just put it in there. Let's put a 3 in the denominator. If we do that, what else do we have to do? We have to put a 3 in the numerator as well. Okay? All I'm doing is multiplying by 1. Nothing fancy here. Just another way of looking at this problem by throwing in the stuff that I need in order to make stuff work. So when I do this, what I get is something that looks like that now, right? All I've done is just multiplied by 1 to make the thing look the way I need it to, and now I can actually evaluate this limit, right? One thing I can do first, I can pull the 3 outside because I can pull constants past limit signs, remember? I can pull the constant outside, and then what I'm left with is the limit as theta goes to 0 of sine of 3 theta divided by 3 theta. What's the limit of that function right there? Okay? The limit of the whole thing here is going to be 3. The limit of just this part is 1, just like over here. Okay? And so here we can find that by using some good substitutions, by manipulating the expression in legal ways, we can arrive at a limit value of 3 in this case. Okay? All right. Now, what I want to do is I want to look at evaluating number 2 over here. Okay? Now, evaluating this limit will essentially rest upon the limit at the top here. It may not be completely clear yet how to get that limit to use that thing at the top there, but what might we try? What might we try? I mean, notice I can't just plug the 0 in, right? I can't plug 0 in because cosine of 0 is what? Cosine of 0 is 0, right? And if I was to just plug in the 0, I'd get 0 divided by 0. I don't know what that is. That can be anything we want it to be. Okay? So I need to figure out how to manipulate this little expression here in legal ways. I can't, just multiply by one thing. I have to make sure that if I multiply, it has to be multiplication by 1. Okay? So how can I get this into a different form that will hopefully allow me to evaluate it? I can't make that substitution. Remember, 1 minus cosine is not sine. 1 minus cosine squared is sine. Okay? How can I get a 1 minus cosine squared out of this? The way I can get a 1 minus cosine squared is I can multiply the top and the bottom by 1 plus cosine. Okay. In this case, again, something that you have to check. Now, it's a pain in the butt, but you have to check something like this. I need to make sure that what I'm multiplying by is really not 0 over 0. Okay? Notice when I plug in theta equals 0, the top here becomes what? 2, right? 1 plus cosine of 0 is 2. So this is okay. I can multiply by this. Okay, this gives me a legitimate 1 divided by, or a 2 divided by 2. So that's a net multiplication of 1. So I can do that. And when I do that, the top now does become 1 minus the cosine squared. The bottom becomes, and I'm going to leave it factored, theta times 1 plus cosine of theta. All right, so made my multiplication. I've got this new expression here. Now what I want to do is I want to simplify it. How do I simplify it? Well, what can I do with the top here? Not cosine squared, but sine squared? Okay. Sorry, I thought I heard cosine. Okay, so that's a sine squared of theta over, and then theta times 1 plus cosine theta. All right. All right. Now what? Any thoughts? break this up into the limit as theta goes to 0 of sine of theta over theta times the limit as theta goes to 0 of sine of theta over 1 plus cosine of theta. Okay? I'm just breaking this up into a product. Again, I'm allowed to do that. I'm allowed to break up multiplications into multiplication of limits. Okay? All right. Limit of the first part. This is 1. What about the limit of the second part? 1/2. Not 1/2. What's sine of 0? Sine of 0 is 0. So the nice thing is that the top here is 0. What's the bottom? 2. So 0 over 2 is 0. So I get 1 times, all right, just like that to indicate what we've done. Lucky for us, that limit all equals 0. Okay. A lengthy little bit of work here, but in the end, it evaluates down to something very simple. And all we had to do was just make some nice substitutions, make some nice multiplication by 1s, okay? Replace the 1 minus cosine squared with the sine squared, and then just break our limit up into a nice way, and out comes the answer we're looking for. Okay? All right. We're going to do a couple more of these just to make sure that we're familiar with how to utilize this limit and its properties. And then we will proceed further. Questions before I put up additional ones? Nothing? All right. Question. Keep on moving along. Okay. All right. So. Again, evaluate some of these. First one, sine of 3 theta divided by 4 theta. Second one, limit as x goes to 0 of tangent of 2x divided by x. And then the third one, limit as x goes to 0 of x squared minus x plus sine of 3x, all divided by 2x. Okay. All right. So just some simple limits. Take a moment. Try to figure out what you think the limits are going to be, and then we'll go through and work them and see if your answers coincide with what we do going forward. Okay. Take a minute. Okay, please. About the first one here. What can we do with the first one so that we can get it to a form we can evaluate? Actually, before we get to that, what do you think the limit on the first one's going to be? 4. See if we can justify that using our properties of limits. All right, so the first thing we're going to do is what? Sine of 3 theta over 4 theta. What's the first thing we should do to get to this limit of 3/4? How do I need